Hello student, today we are going to discuss about the Pinacolone rearrangement, right? So on the basis of name we can identify there is a all. So we can say that there is a dealing with the OH type material, so we can easily identify that if in reactant there is a OH type functionality, then we can identify that it's a type of Pinacolone rearrangement. So in Pinacolone rearrangement, 1,2 diol functionality, 1,2 diol. So this 1,2 diol on reaction with acid catalyst, it is converted to ketone. So this is the principle of the reaction. Acid catalyzed 1,2 diol is converted to ketone is known as Pinacolone rearrangement, right? So your starting material is 1,2 diol and the product is ketone group. Clear? So let me take one simple example. For example, any diol functionality is there. So I am simply put the R group over here on the presence of H2SO4, or we can say that concentrated sulfuric acid. So here concentrated sulfuric acid act as a acid catalyst and your product is ketone. So the number of carbon remains same throughout the reaction. Okay, now let me discuss one more topic. For example, if you have carbocation group, now this carbocation is stabilized by two ways. It can be stabilized by two ways. First way is that if nearer to carbocation, if we are adding electron donating group, if carbocation is attached with the electron donating group, then this carbocation is considered as a stable in the sense we cannot isolate that carbocation, but it gives stabilized carbocation. Now the second way is that, suppose I am giving three example. For example, one carbocation attached with the one phenyl ring, right? This is A. Suppose the second one is one carbocation attached with the two phenyl ring, so one pH, second pH. And the third case is that one phenyl ring is attached with, one carbocation is attached with the three phenyl ring. So suppose if we zoom out this species, so here benzene ring and this is attached with this carbocation. Now we know that this benzene ring is in conjugation with the carbocation, so we can say that this bond transfer to here, this positive charge comes here, then this positive charge comes here, and this positive charge comes this here, right? So here carbocation's positive charge is in resonance with the one phenyl ring. Clear? Now as we know that by increasing the number of resonance structure, the stability of the molecule is also increasing. So we can say that here one carbocation is in resonance with one phenyl ring, here one carbocation is resonance with two phenyl ring, here one carbocation resonance with three phenyl rings. So we can say that C is more stable, C carbocation is more stable than the B, than the A, right? So carbocation can be stabilized in two ways. Either we attach the electron donating group nearer to carbocation, or we can add functionality in which carbocation is in resonance, right? So if number of resonance structure increases, stability of carbocation also increases. If electron donating group is increases, stability of carbocation is also increases. Now this concept is used in this reaction, that's why we are going to discuss here, right? Okay, let me move towards the mechanism part of this reaction. So let me take the same species 1,2-diol. Let me consider the remaining valency of carbon as R. Now, as we discussed in the reaction that we are going to use concentrated sulfuric acid. So acid always donate the H plus. Acid always donate the H plus. Now H plus attack at the site where electron density is maximum. So we can say that here 2 OH group. So oxygen carry 2 lone pair of electron. So here 1 lone pair of electron of oxygen attack with the H plus. So here R C, right, remaining R is as it is, 1 OH group is as it is, and 1 OH group is attached with one more H, which is comes from the sulfuric acid. So here oxygen carry 3 valency, that's why it's positive charge. Now as we know that the oxygen is more electronegative group, so oxygen never possesses positive charge, that's why it attracts the bonding electron pair toward itself and leave from the molecule as a water molecule, right? Okay, now the bonding pair transfer to oxygen, that's why this carbon is now positively charged. Or we can say that in Pinacol rearrangement, carb cation is generated as a intermediate, right? So here this carbon as a carb cation and this is the intermediate, right? Now to stabilize this carb cation, this oxygen now play the role. So the lone pair of this oxygen participate in the bonding to form the double bond over here. If we create double bond, then the carbon valency exceeds the 4. So out of this 2 R group, 1 R group transfer from this carbon to carb cation containing carbon. Now see the arrow notation properly. Here R group transfer from this carbon to this carbon with their bonding pair of electron. So we can say that it's a one type of anionic shift. It is anionic shift because this R group transfer with the pair of electron, or we can say that negatively charged. That's why it's known as anionic shift. So now the next species is here R, here R. These are transferred from this carbon to this carbon. So one more R group is here. Here carbon oxygen double bond, right? Carbon oxygen double bond. Here oxygen valency is 3, that's why it's a positively charged. Now this carbon also contain one R group, so here one R group as it is. Okay, as we discussed in earlier that whenever in starting of the reaction, if you are adding something, at the last of the reaction always remove. So in starting we added the H plus. Now we are going to remove the H plus to stabilize this oxygen. So here removal of H plus and our final product is ketone. So the mechanism is somehow simple. So which is the ketone, right? So in the first step, addition of H plus, after that removal of water molecule, later on anionic shift, and then removal of H plus to form the ketone, right? So I have discussed the stability of carb cation, and this will act as a crucial role in this reaction because there are 2 OH. So which OH get protonated first depend on this R group, right? Depend on this R group. So see here that here carb cation is generated. So this 2 R group should be in same like that it can stabilize the carb cation, राइट ये दोनों ग्रुप ऐसे होने चाहिए कि वो कार्ब कैटायन को स्टेबलाइज करे, राइट. सो H प्लस का अटैक AOH पे करवाना है या AOH पे करवाना है डिपेंड ऑन दिस R ग्रुप. जो भी R ग्रुप कार्ब कैटायन को स्टेबलाइज करते उसको पहले निकालना है. जो भी R ग्रुप एक कार्ब कैटायन को स्टेबल करते उसको पहले निकालना है. मीन्स वी आर गोइंग टू ऐड H प्लस ऑन दैट OH ग्रुप. Clear? Now let me move towards the application part of this reaction. Let me take one simple application. For example, if we have, first of all, we put dial over here at vicinal position. nearer carbon which is known as vicinal position. Suppose remaining valence is satisfied by the methyl group. Right? Now this molecule itself known as Pinacol. This molecule particularly is known as Pinacol. Pinacol is not a name of scientist, it's a name of molecule. So by adding H plus, so let me discuss the mechanism this example. So first of all, H plus can attack on any of these OH group, because here 2R group is also same, here 2R group is also same. So we can say that here OH2 which is positively charged, right? I have added H plus on this OH. So one methyl group is here, Me, also known as CH3. Okay, now in the next step, removal of water molecule. So here minus H2O, C, this carbon is now positive charge, 2 methyl group as it is, here OH, same here, 2 methyl group as it is. Now this oxygen participate in the bonding. Out of this R2R group, 1R group transfer to this carbon, right? Transfer to this carbon. So we can say that it's a anionic shift. Anionic shift. So here C, 3 methyl group, that means 1 methyl group comes from the nearer carbon. Here C, doubly bonded OH which is positively charged, 1 methyl group also here, right? To 1 methyl group transfer to here 1 methyl group as it is. And in the last step, removal of H plus. So the final product is ketone. So here it is not required to judge where exactly H plus are attacking, because all the R group is same, right? All the R group is same. Let me take one more example in which this 2R group and this 2R group is differ. Okay, second application, suppose we take diol. Now this carbon is attached with 2 methyl group and this carbon is attached with 2 phenyl ring. So as we discussed in this class that 2 methyl group acts as a donating group, 2 phenyl ring act as a resonance effect, right? So in short we can say that this if we put positive charge over here, then it will influence by the 2 phenyl ring, but if we put positive charge over here, then it influenced by 2 donating group. Now as we know that the resonance effect is always dominating, right? Resonance effect is always dominating, right? That's why we are going to add, or we are going to generate carb cation on this carbon. Now to generate carb cation on this carbon, we have to attack H plus on this OH, right? So by addition of H plus, so C, this OH is converted to OH2, so oxygen is positive charge, here phenyl ring as it is, and the 2 methyl group as it is. Now in the next step, removal of H2O and removal of H2O. So this carbon is now positive charge which is in resonance with 2 phenyl ring, and that phenyl ring is responsible for the stability of that carb cation. That's why we are generating carb cation on this carbon, right? So this carbon is influenced by 2 phenyl ring resonance. Now anionic shift, out of this 2 methyl group, 1 methyl group transfer to here. So pH, C, pH as it is, 1 methyl group comes from the nearer carbon, here C double bond OH which is positively charged, 1 methyl group also there, and then last step, removal of H plus. So the final product is ketone. This carbon contains 1 methyl and 1 phenyl ring. Okay, now one more confusion is that if instead of this 2 methyl group, one is something else and the second is something, means this 2 is different, at that time we are going to transfer here that functional group, that group which can stabilize the carb cation, right? So ultimately हमें क्या देखना है, एक carb cation more stable होना चाहिए, ये कार्ब कैटायन की स्टेबिलिटी सबसे ज़्यादा होनी चाहिए, राइट। यहाँ पे भी हमें वो देखना है, हम जब यहाँ से ग्रुप यहाँ पे ट्रांसफर करें तो वो ग्रुप भी इसको स्टेबल करना चाहिए, बिकॉज अल्टीमेटली इट्स इलेक्ट्रॉन डेफिशिएंट. So we have to move out of this 2R group which can stabilize this carb cation, right? Okay, now third part. This is somehow interesting part. Suppose instead of two diol group, suppose I am taking here NH2. It is also Pinacol rearrangement. 1,2 डायल की जब अब एक OH तो होगा ही, यहाँ पे कुछ और होगा. क्या होगा वो यहाँ से डिसाइड होगा. Suppose I am adding to add NaNO2 and HCl. So instead of concentrated sulfuric acid acid catalyst, we are going to use sodium nitrate and hydrochloric acid. Now as you know that these two reagent is used to generate N2 diazonium salt. This is simply diazonium reaction. NH2 react with the NaNO2 and HCl, it generates the diazonium salt. So first one, it is converted to here OH as it is, here phenyl as it is, right? So here it is converted to N2 plus by this NaNO2 and HCl. So here CH3 as it is, here H as it is, right? Okay. So in this case we are not going to decide where exactly H plus are going to attack, because यहाँ पे जो reagent दिए वो इन दोनों में से किसी एक को निकाल सकते हैं. इसको निकाल दिया, कार्ब कैटायन यहाँ पे जनरेट हो गया. सो हमें ये डिसाइड करने की जरूरत नहीं है कि H प्लस का अटैक कहाँ पे करना है, राइट. सो नेक्स्ट स्टेप यहाँ से निकल जाएगा, बिकॉज वो स्टेबल मॉलिक्यूल है. और हमने बात की है कि अगर ड्यूरिंग द रिएक्शन इफ एनी सिंपल मॉलिक्यूल इज रिलीज देन ऑलवेज डू दैट. सो यहाँ से NH2 minus N2 निकल जाएगा, मीन्स नाउ दिस कार्बन इज एज ए कार्ब कैटायन, right? So this carbon is carb cation, methyl as it is, hydrogen as it is. Now this 2R group is same phenidine. So as we know that phenidine can stabilize the carb cation by resonance. So out of these two phenidine, one phenidine transfer to carb cation by anionic shift. So this step is anionic shift. This double bond, this lone pair of oxygen participate in the bonding. So here PH, C, double bond OH, which is positively charged. One phenidine transfer here, and this carbon contains CH3 and H is it. And in the last step, removal of H plus. So H plus यहाँ से निकल जाएगा, and the final product is ketone. Right? So this is also Pinacolone rearrangement, but here one word is now used. It is known as Pinacolone rearrangement, right? Because यहाँ पे हमारे पास दो OH नहीं है, एक OH है and one is living group. So this is living group, right? हमने पहले इसको N2 प्लस में कन्वर्ट कर दिया. N2 प्लस इजीली रिमूव फ्रॉम द मॉलिक्यूल. हमें अल्टीमेटली क्या करना है, कार्ब कैटायन जनरेट करना है. दो OH ग्रुप हो तो H प्लस ऐड करवाना है. अगर एक OH और एक दूसरा ग्रुप हो तो उसको निकाल के यहाँ पे वहाँ पे कार्ब कैटायन जनरेट करना है. सो दिस इज नॉन एज सेमी पिनाकोलोन rearrangement. Let me take one more example of semi Pinacolone rearrangement. Suppose we are going to use here one OH as it is, here methyl, and here instead of methyl we are going to use Cl, right? So chlorine can be removed by the silver. Suppose here silver is there, then Ag attached with the Cl minus, here Ag plus, Cl minus. So here removal of AgCl white precipitate. आपने प्रैक्टिकल में देखा होगा, it gives white precipitates, right? So now this carbon is positively charged, right? So here CH3, COH as it is, here CH3 as it is, and this carbon converted to carb cation. Now out of these two near R group, one is transferred to carb cation group. This oxygen participate in the bonding. So here doubly bonded OH, which is positively charged due to trivalency. This methyl group transfer to carb-cation site, and in the last step removal of H plus, right, to stabilize this oxygen, and our final product is ketone, right. So this is also example of semi-Pinacol Pinacolone rearrangement, right. So out of this 2 OH group, 1 OH group is replaced by some other functionality, or we can say that some other living group which can live from the molecule easily, and it generate the carb-cation. So in short, carb-cation is important part in this reaction. Carb-cation is important part in this reaction, right. Now let me take one more example which is somehow different, but if you apply the concept then you can sort out the any example. Suppose this is your starting material, 1 OH here, 1 OH here, right. So 1,2-diol is also there, right. If we are going to add H plus, or we can say that considered sulfuric acid, so 1,2-diol considered sulfuric acid, so it's also a Pinacolone rearrangement. So first of all, attack of lone pair of oxygen on H plus. So first of all it is converted to OH2 plus, here OH as it is. Now this OH2 plus remove from the molecule as a water molecule, right. So now this carbon is positively charged, and here OH as it is, right. So अगले स्टेप में हम क्या करते थे, ए वाला लोन पेयर यहाँ पे हो रहा है, अब ट्रांसफर किसको करना है, यहाँ ये दोनों बोन इधर इसको ट्रांसफर कर सकते हैं या इसको ट्रांसफर कर, किसी को भी करो, दोनों सेम ही है, राइट. वो तो हमने दिखा है इसलिए, बाकी दोनों ग्रुप सेम ही है. सपोज दिस बोन ट्रांसफर फ्रॉम विद द एनामिक शिफ्ट है ना, मीन्स ए बॉन्डिंग इलेक्ट्रॉन लेके यहाँ पे अटैक कर रहा है, ए बॉन्ड अपना बॉन्डिंग इलेक्ट्रॉन लेके यहाँ पे अटैक कर रहा है. दैट मीन्स सपोज वी आर गोइंग टू नंबरिंग, सपोज दिस OH कंटेनिंग कार्बन 1 2 3 4 एंड 5. दैट मीन्स फर्स्ट एंड फिफ्थ नंबर का जो बॉन्ड है वो ब्रेक हो रहा है, वो अपना इलेक्ट्रॉन लेके यहाँ पे कार्ब-cation पे अटैक कर रहा है. सपोज ए रिंग तो ऐसे ही है ना, तो उसको हम पहले ड्रॉ कर देते हैं, दिस रिंग एज इट इज. नाउ दिस कार्बन अटैच विद फर्स्ट कार्बन, नाउ फिफ्थ कार्बन इज अटैच विद दी कैटायनिन कंटेनिंग कार्बन. ये पहले किसके साथ कनेक्ट था, फर्स्ट के साथ, अब किसके साथ कनेक्ट होगा, यहाँ पे, राइट. सो ये वाला हमारा फर्स्ट नंबर कार्बन, सेकंड, थर्ड, फोर्थ एंड फिफ्थ, फर्स्ट, सेकंड, थर्ड, फोर्थ एंड फिफ्थ कार्बन. नाउ फिफ्थ कार्बन अटैच विद दी carb-cation carbon, so it is attached with the carb-cation containing carbon. Now first carbon is attached with the OH, so here doubly bonded OH which is positive charge. चलो नेक्स्ट स्टेप में हम क्या करते हैं, रिमूवल ऑफ H प्लस, राइट. यहाँ से H प्लस नहीं कर रहा है, दैट मीन्स इट इज कन्वर्टेड टू नाउ कीटोन, राइट. सो आवर फाइनल प्रोडक्ट इज ऑल्सो कीटोन, बट इट इज नाउ साइक्लिक कीटोन. ओके, नाउ हाउ मेनी रिंग इज देयर, 1 2 3 4 5 and 6 members. So one is 6 member ring, and the second one is 1 2 3 4 and 5 member ring. So one is 5 member ring, another one is 7 member ring, and one atom is common between these two ring. So this is the 5 member ring and here is the 6 member ring. अगर हम इसको अच्छे से ड्रॉ करते तो ऐसा रहेगा. ओके, ये वाला सेकंड नंबर कार्बन है, इसके पास वाला कार्बन फर्स्ट वाला, मीन्स ए फर्स्ट वाला है, फर्स्ट के साथ क्या है, कीटोन, है. सो दिस इज अवर फाइनल प्रोडक्ट. अगर आपको पता, दिस टाइप ऑफ मॉलिक्यूल इज नोन एज स्पाइरो कंपाउंड, रेडी. दिस इज नोन एज स्पाइरो बिकॉज वन एटम इज कॉमन बिटवीन टू रिंग्स. इफ वन एटम इज कॉमन between these two rings, then it is known as spiro compound. Okay, now I am going to give you two questions for your practice. First one is the, suppose cyclohexane 1,2-diol by acidic condition, so you have to give me the final product. And the second one is same cyclohexane type material here is the OH, here is the NH2 by using NaNO2 and HCl, and you have to give me the final product. Let me take one more example. Suppose one OH is here and the second OH is here. So by using acid catalyst, you have to give me the final product. So these 3 questions you have to solve by yourself, and in next lecture you have to give the final answer, right? Thank you. Have a happy learning.